the ramp is cosine. We've gone through it once here. Oh, let me do it the other approach. But what I'm getting towards is, I'm hoping that for things on a slope like that, we can just jump straight to force sine theta and force cosine theta without having to go through the derivation every time. If you're still stuck on it later on, please feel free to ask.
Does that mean then on an exam, we don't need to show our work to get to this point? We can just say that the, like, down the ramp direction, probably the positive I-hat direction is.
Yeah, you can jump straight to it. Brooke?
So we don't have any units to find out what these proportions are yet. Are we gonna be given units, or are we just gonna, is this just part of solving?
This is generally when you, in physics, you solve it without plugging any numbers in to begin with.
Okay.
So eventually I'll throw numbers up on the board. Loiza?
So I see why you drew that first triangle, but like, so in the second one where you had like the one with the, like, with the theta prime and stuff, like, why did you, like, what is that gonna help us find, like?
I was trying to justify that this angle right here is theta. So this was the sort of the geometry that for a right triangle, I have a right angle, and the other two add up to 90 degrees. So whatever this is the complement of it. This is 90 degrees minus whatever that is.
Okay.
And that's a right angle there, so this has to be the complement of this.
So those are the, so those two are the same triangle, but you flip them so that you can show where the theta prime is?
Yes. Now, you get onto a test, whatever your mind's gonna do at that point, hopefully you're thinking, oh, down the ramp, W sine theta, into the ramp, W cosine theta. However, you suddenly panic. You second guess yourself. Not that that would ever happen in physics, but you second guess yourself. You know one of them is gonna be W sine theta and the other one's W cosine theta. What you could do, instead of drawing everything to make it look like a 45-degree angle, if the angle is under 45 degrees, exaggerate it. If it's over 45 degrees, exaggerate it. Now what that does is, I know weight is going down, and I'm going to break it up into perpendicular components, one of which is along the length of the ramp, and the other one is perpendicular to the ramp. In my two incredible drawings right here, this down the ramp is clearly the larger of these two. Over here, this one is the larger of the two. So I go in my calculator, I type in sine, I type in cosine, I see which one's bigger. If it's under 45 degrees, the bigger one's gonna be cosine. If it's over 45 degrees, the bigger one's sine. Try to draw it somewhat realistic, and then you can look at the two numbers and go, oh, okay, this one's the bigger one, so okay, I'm gonna put that down for the bigger one. That's the other approach, or an other approach. All right, so back to the force diagram. So what I'm claiming, all I've done is I've added these two vectors here. So weight acting straight down is the same as W sine theta I hat minus W cosine theta J hat. Because I'm adding head to tail. So my force diagram, I have normal force acting this way, I have friction acting that way. Down the ramp, I have W sine theta. Into the ramp, I have W cosine theta. Now, I've not drawn the arrows to any particular scale. This is just, well, we're doing this analytically, so we don't really need to have a scale. Equations of motion. Equations of motion are all based upon F equals ma. And again, I said this before, probably say it again at some point. These are not the cake formulas. Equations of motion are not the cake formulas. This is considered the equation of motion. I have forces in the I hat direction, I have forces in the J hat direction, so I am going to have an I hat equation, and I'm gonna have a J hat equation. So in doing your equations, you take all the forces in the positive direction, you write them down with a plus sign in between them, minus the ones in the negative direction, and that's equal to the mass times the acceleration in that direction. So, what would be what am I writing as far as the sum of forces over here?
W sine theta minus friction.
Equals mass times, we've established that acceleration is in the I hat direction, so my I hat equation has an acceleration here.
Positive.
I would expect acceleration to be
Yeah.
positive. Yep. If I get a negative acceleration, that can mean a couple of things,
Like going back up the ramp?
which means that either made a mistake or it's not moving.
Is this on there?
It doesn't change anything we've done so far, but I would picture it on Earth.
Oh, right, numbers aren't going in there.
All right, my J hat equation,
W cosine of theta minus y, or is it y minus W cosine of theta?
which one is it?
Y minus cosine, W cosine of theta.
And that's based purely on the fact that I said J hat was positive in the Y direction.
Alright.
So W cosine, wait. Where's the Y? Oh, okay, I see.
And what's that equal to?
That's,
Zero.
oh, yeah.
The acceleration would be zero.
Yes. Technically, mass times 0.
Why is that equal to 0?
Because the acceleration is down the ramp.
Yeah, okay, never mind, that makes sense, cause we don't have like horizontal acceleration.
Right. And, all right, there are the equations of motion. At this point, almost a math problem. We have to do one more step before we make it a math problem. Substitution. There are formulas. So W, what's the formula for weight?
Mass times acceleration due to gravity.
Thank you. Gee,
Gotta screw it up at some point.
I slipped up.
you could just say mg and just be done with what to call it. All right, so we're gonna make that substitution. Again, these are the independent formulas that have nothing to do with the problem itself. These are just sort of, I hate to say universal truths, but what we consider universal truths. So we're gonna substitute in for weight there and weight there. And friction, for right now, I'm gonna make friction equal to 0. And I'm gonna indicate that by just saying that mu sub s equals mu sub k equals 0, and that's just saying that it's frictionless. Friction is a whole new set of complications I don't want to worry about at the moment. And so my equations become mg sine theta equals ma, and y is equal to mg cosine of theta. In a frictionless problem, the second equation is not going to, it has no bearing whatsoever. One comment about when Henry started out with W cosine theta minus y, since it said equal to 0, you would have gotten to the exact same place. It would not have affected the final result.
The only issue with that is I had them swapped, like, if it were that, it would be negative W cosine theta plus y. You know, it'd
Yeah.
just be the same thing, I wasn't thinking about it the right way.
Okay. We're solving for acceleration. And so acceleration is just equal to g sine theta.
Question about the like mu s, is it supposed to be equal to mu k, or mu sub s is equal to mu sub k, or was it?
In this
supposed to-
case, yes, they're both equal to 0.
Okay.
So now we need to know what planet it is and what the angle is. Notice that the mass of the box is irrelevant. On a problem like this, oftentimes I won't even give you the mass. If I don't give you the mass, one of two things, it means one of two things. One, it means you don't need it, or two, I made a mistake. Flip a coin. More likely you don't need it, but occasionally it's because I forgot to get it. And so if we were on Earth, and theta is 30 degrees, then the acceleration of the box would be 4.9 meters per second squared.
How's that song go? Earth angle?
Oh.
I'm just messing. I don't know why that.
Earth angle.
Yeah, that made me think of it.
Is it 1 degree line?
Yeah.
Wait, where is that from?
It's a song.
Earth angle.
It's, yeah.
From the 50s?
Okay, but like, is this actually like a universal thing that we need to know? Just like Earth angle?
No, that's, you plug in 9.8 for G, and you plug in 30 degrees for theta, and you get
Oh.
4.9.
Okay. Wait, how do we get the 30? Did you just get?
I just said, hey, let's put it on
This
Earth
is the
and let's
angle.
make the angle 30 degrees.
Okay, cool.
And I know sine of 30 degrees is a half, that's how,
Yeah.
it's one of the classic angles. All right, questions on this one, because now I'm about to do the same problem except a lot harder. I'm gonna at least set it up, I'm not gonna solve it, because it's a pain.
Okay, sorry. So we set up both of these equations, but we only really needed the one to find acceleration because there was only one variable missing, right?
Correct.
Okay. Last time it was much longer because we had two missing variables, right?
Wait, if I needed to know the normal force, we would need to know the mass. Generally, normal force is gonna show up when we need to know friction, and I made it frictionless.
So if we're just solving for acceleration, would we still need to set it up the way we did with both the I hat and J hat directions, even if we're only using one of them?
I strongly recommend it. If I say, what are the equations of motion, then yes, I do expect both.
Okay,
If all I did was give the initial problem, said, what's the acceleration, then that's up to you.
okay.
All right, so let's do this the hard way. So, okay, I'm okay. So everyone's okay if I erase? Well, we know the answer. Now, occasionally students really love to do that as your coordinate system. Not recommended, and here's why. So let's make I hat to the right and make J hat up. Now what am I breaking up?
All of it? All of it?
You're breaking
Not all
up
of
two
it.
forces.
Or everything but weight, yes.
Okay. So normal force and friction have to be broken up. So we'll start out with normal force. Actually, friction might be a little bit easier. So friction's going this way, and I'm breaking up into perpendicular components that are vertical and horizontal. I know this angle is theta.
So it's friction sine of theta and like friction cosine of theta.
Which one's
Okay.
sine, which one's cosine?
This one is sine and then this one's cosine.
So F sine theta, F cosine theta.
So we would just have to do it for more than one
Yeah.
value, which is why you're telling us to.
Yes, you'll have to do it more than one, and this is not why it's a pain to do. This is minor compared to what's coming up. All right. Now, normal force is perpendicular to it, so when I have normal force this way and I'm breaking it up, since they're perpendicular, the trig functions will switch. So cosine was true for the horizontal here, it's gonna be sine for the horizontal here.
Why?
That was sine, because they're perpendicular.
Because theta's in a different spot.
Okay.
That would be theta. And this is why cosine of theta.
Is that why it's a pain?
No, not that.
Okay.
So now my force diagram, or I have weight acting down. I have y sine theta acting to the right. I have f cosine theta acting to the left. And then I've got f sine theta up and y cosine theta up. So there's my force diagram.
Yeah. Okay.
That seems a lot simpler. I don't know what y'all are talking about.
Yeah, well, however your mind is working at the moment, equations of motion, and now we'll get into why this is a nuisance. What are my equations of motion here?
I literally could, I don't know where to start. Like-
Well, force is equal to mass times acceleration, so we've got, and then are we still going to, yeah, the mu of s, sub s is equal to mu of sub k, so,
Let's still put friction into the equations of motion.
So would
okay.
it be y sine theta minus f cosine theta for the I hat direction?
Equals.
No, what is it?
Equals mass times the acceleration due to gravity? No,
No, it's equal to zero. I don't know.
It's not zero.
It's
times
just our acceleration that we're solving for, right?
No, because our acceleration that we're solving for is down at that angle right there.
So we have to split the acceleration.
Oh.
into
Yeah,
components.
that's why it's a pain.
Goodness.
I'm gonna call this a sub one and a sub two.
Sheesh.
Okay,
So this is mass times a sub one.
got it.
All right, so now here,
Okay.
Uh,
Let's see, we've got,
y cosine, no, yeah,
Yeah.
y cosine of theta minus,
wait,
You add them together?
wait,
there's three forces there, so,
minus weight
So it's just
so
plus.
minus weight.
is equal to,
Plus
we
f
left one
sine
off.
theta?
Plus
f cosine of theta.
oh,
F.
okay.
Sorry.
F
Sine of theta.
sine theta is equal to mass acceleration sub two.
Oh, no, there's a small little mistake there.
Mass is not gonna be the same as top one.
We're
Oh,
not
no, the
accounting-
masses will be the same, okay, there.
We're not accounting for gravity? Sorry.
The acceleration of gravity is gonna show up
Oh.
under with weight.
Well, now it's not just gonna be a pretty zero, the acceleration won't be zero.
Well, that's true, but there's still a mistake, even, you should still be able to get to the right answer doing it this way. What's the direction of A2?
Down,
Oh,
it's negative, okay.
Or if you left it positive, then you, somewhere in your head, you have to go, all right, I'm expecting A2 to become a negative number because I made this positive and A2 is down.
yeah.
All right, now our unknowns. Presumably we'll know the mass, even though the mass still should not make a difference. We don't know normal force. We don't know A1 and we don't know A2. We have three unknowns.
And the other one, we have one.
Well, we didn't know normal force also, so technically there were two unknowns, but we have three unknowns, so we have to have at least three equations.
So will we ever have a problem like this? Where we have to use?
Oh, where you have to do it the hard way?
Yeah,
No, doing it the hard way is student choice.
okay.
The third equation is the relationship between A1 and A2. A1 squared plus A2 squared is equal to A squared. Pythagorean theorem. So you basically would solve for A1, solve for A2, plug it in here, and then just have fun. Or actually probably solve for Y. Or
Basically,
change your
don't do it
coordinate
this way.
system. A great deal of physics is spin, I've probably said this several times already. More advanced physics is trying to find, a lot of time is spent trying to find a coordinate system that reduces the amount of math you have to do. And so, it's really a lot more convenient doing it the first way we did this. And then,
That's the most important rule.
that's right. For the masochistic math people in here, go for it, you would have fun.
Math is fun when the Greek alphabet stays out of it, you know?
Yes,
You,
I agree.
you've got enough language with English already, and then trying to use some dead language that hasn't been used for centuries, you know, kind of,
The Greek alphabet hasn't changed in modern Greece.
yeah.
like already throwing letters into math is already like pushing it a little, and then you have these other ones, so.
And then using numbers that don't even exist. Like, what is pi?
Pi exists, just
Or-
not in
It's
our
just like-
world.
It doesn't exist in our world.
I mean,
It
it's
does.
theoretical, isn't it?
My birthday's Pi Day.
No, it's an actual,
Oh,
It's a
you're
real
saying because it's
thing.
irrational or something?
no, I thought
Yeah.
that it was just like a function value, not in the sense of like X, but like you put it in to get like close enough to an answer that you would know within a margin of error what this would be, like, you know.
Okay.
Yeah, you can't have pi over 6 because pi is like a huge number. So and I think they're discovering more numbers to pi, aren't they, or something like that?
Yeah, there are formulas where you can calculate pi, so you can take pi out of many digits you got capacity to handle. All right, at this point, it's just more of the same. So what we're gonna do now is I'm gonna do book and cut problem. Where we've got different coordinates, clearly different coordinate systems for the two masses. This is the book. The month. I'm gonna tell it how, just because I use M for mass. I'll just say 10 meters per second squared, up the ramp, whoa. Now let's make it 15. 15 meters per second up the ramp.
Book is moving up the ramp.
Yep.
Okay.
So when the system starts out, and we come back from commercials, this book is moving this way, dragging the cup up with it.
There are no other forces involved in this?